Okay, so we are going to continue on in our PowerPoint presentation and in our book. You will notice that we're going to skip some sections here and we're going to go to section 4.7, and it's called Limiting Positions, Graphical Analysis. Remember, in this book, we are covering a number of chapters throughout in each one of the sections or the modules that we go through, but we're not always going to cover each and every section, okay? So it's important to use the PowerPoint presentation as your guide through the chapter, because anything that we're not covering in the chapter, you're not going to be responsible for. The things that we skipped over, if you're wondering, are those what we call the analytical solutions, and those would be calculating values based on application of math, okay? So what we're going to be focusing on, as I talked about earlier in our term, what is that we're going to be looking at the graphicals only. You get a lot of opportunities in other classes to apply the trig and the algebra and the calculus. This is just going to be one area we're going to focus just on the graphicals, okay? So so that's why we're kind of skipping over a couple areas here. But let's talk about limiting positions. So what is limiting positions? Limiting positions are when we configure our mechanism so that it places the output in its furthest away position, and then it's the output also in its closest position. Now, depending if we are either a linear output, like a slider, okay, or piston or a cutter or whatever it might be, in that case, that's going to be linear displacement, as we've talked about. And once we know what the furthest and the closest away position is going to be, we can measure that distance, and that's what we call the stroke. Okay, so it's the difference between what we call the two extreme positions, whether it is furthest out or closest. Okay, if we look at figure 425 in our book, we are going to see the idea of limiting positions for two different types of mechanisms. I got to pull up my camera, so just give me a moment. I did not do that. Here we go. All right. So on the top of page 88, you will notice that we have two diagrams here, okay? The top diagram is a slider crank mechanism, okay? And what they have here is they have a couple positions of that output or the slider portion of the mechanism. Now, you'll notice that the furthest point out, furthest to the right, and the closest to the left, the difference between those two we're calling the stroke, okay? We call it stroke when it's a linear displacement, okay? So this is the total displacement of that mechanism. And all that means is that it's limiting positions, okay? It's closest and it's furthest away, okay? The difference between those two, that maximum amount of travel is going to be called the stroke, okay? Now, this middle one is just an intermittent place. And we see a lot of the mechanisms that we've been drawing lately kind of just as at a random place in what we would call the cycle. As we look at how far it's going to go out and how close, this gives us a better look of what is the total amount of travel that we're going to see, or in this case, what is the stroke, okay? When we have a mechanism that is, for instance, a standard 4-bar mechanism, and in this case, there isn't a slider on the output, okay? We've got a crank that goes around 360 degrees, but our output is going to oscillate back and forth. We call this a crank rocker, if you remember from Module 1. This was one of the kind of the standard 4-bar mechanisms that's out there. Now, in this case, this output length is fixed, has a fixed point of rotation at point D, okay? And what it's going to do, instead of sliding linear back and forth, it's going to oscillate. And instead of being a linear distance or a linear displacement, this is what we would call an angular displacement. So if we wanted to identify, you know, what the limiting positions were on this output mechanism, okay, or this output link, I should say, we would measure the angle from the furthest to the closest, and this angle then is going to be the angular displacement, or what we call the throw of that output link, okay? So when we have a slider and it moves linearly, we call that stroke, the difference between the furthest and the closest point. And when we have a link that oscillates, that's going to be an angular displacement called throw between the furthest and the closest rotation, okay? Now, so what we're going to do in our examples that are coming up, and then in the homework that applies to this, is we're going to be finding limiting positions. Okay, so we're gonna see what that process looks like. And the example we're going to be looking at is going to be example 4.6. Okay, example 4.6, we have a reciprocating saw mechanism. Okay, so in back of what would be this flywheel, all right, we would have a motor. Okay, and that motor is going to rotate that shaft, which has this flywheel on, which is then going to connect to the connecting link, okay, or connector. And then it's going to oscillate this, or not oscillate, it's going to move this blade back and forth, up and down, if you would. Okay, so we have a slider as our output, which is the blade. And then we have our connecting rod, and then our crank is going to go around in a circle, but instead of drawing the circle here, we're going to represent this simply as a line from the center position, which is going to be our frame. So what I want you to do is, using the dimensions that we see here, we're going to draw the kinematic diagram for this particular mechanism. Okay, now I'm not going to talk through it. I'm going to go over to AutoCAD. Okay. And basically what I'm going to do is I'm going to kind of draw mine in position. I'm going to let you guys do that in the background here as well. And then we'll kind of resume our lecture when everybody's got it in place. So I'm going to just pause our recording for a bit and then be back. Okay, so now that we have our diagram in the random position here, so you'll notice that if we go back underneath, it's not giving us this angle right here. So just assume an angle. I drew mine at 45 degrees, and then that way I could kind of complete everything else. Otherwise, you don't really know where it's at. So, but this is an intermittent position. And what we want to do is we want to find what are the limiting positions for this mechanism. So we want to find out how far is this blade going to go down, and how far up is it going to be? Okay, so what are the what is the extreme positions, the limiting positions? Now, to do that, as you can see over here, this is the kinematic diagram, which is reflected in the one that we drew in AutoCAD. Now, their frame and slider are a little bit smaller, so proportionally it might not look exactly the same, but it's really just the placement of those points, so it's totally fine. So then what we're going to do is, over on the right-hand side, we are going to place this in two ways. The first way, we're going to see how far down this is going to go. And what we're going to do is we're going to take link number 2, our crank, and we're going to add link number 3 as they show it here. Now, from this point going forward, what we are going to do is we're going to kind of start a standard way of numbering our links and our joints, numbering and lettering our links and joints. First of all, our frame, as we know, is always going to be number 1. But then our crank, or our input, is going to be number 2 now. All right. Number 3 is going to be the connecting link, and then number 4 is going to be the output. In this case, the output is a slider. Okay. So to find the furthest out position, or the furthest down position for this blade, we want to add the length of link number 2 and the length for link number 3. And we want to extend that as a radius all the way down, because that means that these are going to be in line with one another and kind of extended to its furthest position. And where it intersects the line of action for that slider is where our furthest down position is going to be. Okay. Then for the furthest up position, we are going to take link number 3 length, okay, right here, L3, capital L is the length of link number 3, and we're going to subtract the length of link number 2. So that's minus L2, okay? And what that's going to be is, that's when this is going to be back here. It's going to overlap and intersect with that line of action. That's going to be the furthest point up. So we're going to draw these two positions now on our diagram to see what we get, okay? So if we go back to AutoCAD, we want to find that furthest down position. So I'm going to go to kind of construct this. I'm going to go to my 0 layer, and from my point A, which is the center of rotation of my crank, I want to draw a radius that is going to be the length of link number 2 plus the length of link number 3. Now my link number 2 is a 1/2 inch, right? And my link number 3 is 1 3/4. So if I add those two together, so this is L2 plus L3, what would be that distance? 2.25 or 2 1/4, right? So now what I'm going to do is I'm going to do a circle center radius, okay? And I'm going to start at point A, and I am going to make that radius 2.25, enter. And now you're going to notice that there is a crossing over the line of action for that slider down at that point. So that's going to be the new position for the slider. Now, what I can do is I'm going to copy my slider down. So I'm going to do a copy here. I'm going to grab my C, but I'm not going to do the hatching just because I'm going to extend the hatching instead, because I can see these are going to overlap. And all I'm going to do is I'm going to then go from that position down to the new intersection that was created. Okay. Now, just like we did in our last module, or the last time that we met, we now need to show this in a new line style. And the line style that we chose last time was called Object 2. We changed the color to green, and we also changed the lines type to hidden. So you probably saved that as part of your start file, okay? If you didn't, then all you want to do is grab a new layer, and you just want to call that Object 2, make it green and hidden, okay? Additionally, we need to change the name of C, point C, because now this is a new position for it. So we're just going to double click on that, and we're going to add that prime, okay? And then I'm going to move it to the other side so that we can see it a little better. So this is C prime. It's a new position. And then I'm also going to move my C so that it isn't overlapping with the letters. Okay? Yes. There would not be a new D, because D is the connection between the slider and the frame. So that just extends down. It's really the same connection, keeping it in line. So there's not a D prime. Good question. Okay, so then now what we want to do is we want to draw the lines from A down to C prime. So I'm going to change to Object 2, line, go from that center to the new center, and that's going to be the extension of the 2. Now, before I go to my next one, what I do need to do is I need to show where link number 2 ends and link number 3 starts. So I know that if I go back to my 0 layer and I draw a circle center radius, link number 2 is 0.5 long, right? So where this intersects right here, that is going to be, I'm glad I'm getting a new computer because I can tell this is like, I don't know, just a little finicky. Doesn't always work the way it's supposed to. Now, you do not, you should put, because B changed, this is going to be a B prime in this new position, okay? A remains the same because that's a fixed center of rotation, so that one doesn't change. But we do have a new B, and that would be B prime. So we've got a C prime and a B prime for our new position. Okay. And then I'm going to get rid of that radius that I just used. Okay. So now this is the furthest down position. We can see that link number 2, A to B, and link number 3, they're like extended in line with one another. Okay, so that's adding up the length of link number 2 and link number 3. Now what we want to do is we want to find what is the highest position this is going to be at. So if we go back to underneath, we want to now take the length of link number 3 and subtract the link number 2. So as we know, link number 3 is 1.75, and we want to subtract 0.5. What would we get for that radius then? 1 1/4 this time, right? 1 1/4 this time. So I'm going to stay on my 0 layer, circle center radius from A, 1.25. There we go. And now you're going to notice that we have a new intersection, and it's going to be right there. All right. Looks like I have to move D. So I'm going to move D out of my way here. I'm going to maybe put that over here for right now. And then now we're going to need to create a new line style for this third position. We can't do it in green again because it's literally a different one. So we're going to go to layer properties. I'm going to click on 2 because I do want to have it in the hidden line, but I'm just going to change the color. So I'm going to select number 2, hit enter, and we're going to call this object 3. And I'm just going to change the green to cyan, that blue, kind of that bright blue color. Okay. Now you can color it whatever color you want. If you're like, you want yellow or something like that, just make it so it's going to show up nicely on the black background. Okay. So now we are going to draw our line on object 3. And we're going to draw the line from the new connection or the new intersection, which is right here, to the center of A. Okay. And then what we need to do is we need to extend that to the outside diameter that has the diameter of a 1/2 inch. Okay. So if you left, oopsie, I have this in the wrong, this is the wrong one. I'm sorry. I need to draw my 1/2 inch radius. I got rid of it. I thought I had it in there. So 0.5, there we go. So then what we want to do is we want to extend that to what would be the radius of 0.5. Do you see that? Because these are going to be overlapped onto one another. Does that make sense? So then now back here is going to be our B prime prime on the back side here. This is really getting super close. I'm going to put 2 over here for right now. I'm going to grab B. Okay. And this is going to be B prime prime on the back side. Okay. And then our upper one that we just created, we need to copy this up to that new position. We're going to change its layer to object 3. And then that is going to be C prime prime. And then I just need my patch and my questions. I'll let you kind of catch up on the labels here. I'm going to put my 2 closer back over here. I'll go on. There we go. And I'm going to do, I guess I didn't do this yet. I'm going to call it, I have to save as, and I'm going to call this one Example 4_6. Now, once we have those in position, the question wants to know, first of all, okay, where are our limiting positions, but what is the difference between that highest and that lowest point, or what is the stroke of this saw blade? Okay, so to do that, we are simply going to go on our notes, or dimension layer would probably be the right one, and we're going to put a linear dimension from our C prime prime, the center of C prime prime, to the center of C prime, and we're going to find out how long that is, okay? You'll notice that we get 1.2655, okay? And if we compare that to what's in the book, their screenshot, if you would, you're going to notice that they get that very same number. Okay, so that means we did it correctly. And again, this is called the stroke because it's a linear difference between the highest, in this case, and the lowest position. Okay, all right. Now, I'm going to move my D because it does not look normal there. So I think I'm going to put it like down here-ish. Okay, and then that will be, this is the final diagram that you need. You need that dimension for the stroke. You need to show C, C prime prime, C prime, B, B prime prime, and B prime. And then the appropriate labels there. I know it's a little bit close, but it's just kind of the nature of it. If you wanted to scale down your frame and your slider, you can, but it still works the way we have it. Okay. Now, once we have this in position, what we're going to want to do is we're going to want to go to the document that you saved last time for Module 2 practice problems. So I'm kind of opening up my Windows or my Word document now. Let me see. Module 2 practice problems. Okay. And you'll notice that I have on here my example 4.1, 4.2. And now I'm going to add my, I'm going to insert my next page. And this is going to be example 4.6. And I need to go back and do my screenshot. So Windows Shift S. And it's in there. I got to put this over here. Windows Shift S. Here, make sure you get that stroke in there. And then I'm going to go back to my Word document and I'm going to add in this example. Okay. Questions? Well, you'll have to play with that during lab, or I can help you during lab if you don't get that number. It's going to be, if you don't get that same file number, there's something probably in one of the dimensions that are there. Okay. And we certainly can go through that, but we'll fix those up individually during our lab time. Okay. So that's example 4.6. I'm going to stop our recording at this time, and then we'll look at our next example.